Okay, so my name is Alex Ivanov, and this talk is CPR for EMR. And I work for NBL Technologies as their pen test lead. I have 6 years of experience penetration testing, and I have alphabet soup for certs and degrees, but I'm not going to list those because the industry is becoming sick of them anyway. A significant portion of my career has been spent in and around healthcare, and I've amassed a great deal of healthcare security, or lack of knowledge, as we'll soon find out. It's not been a bad specialty to fixate on. You know, there are definitely unending problems to be resolved within health information technology security, the protocols, EMR, EHR systems. There's a reason why it's always in the news when we talk about breaches. But I've been performing assessments for accreditation, so my engagements are scoped on strict guidelines, although I always find room for creativity. You never know what you're going to see in a healthcare system, as you'll soon find out. So, who's this talk intended for? Just a quick obligatory MBL slide. We are a consulting firm with specific expertise in state and federal markets, and we do perform commercial engagements and provide a variety of security services, ranging from cybersecurity to privacy and program management. Check us out. So in this talk, I'll discuss healthcare data security and review the most common protocols used for the transmission of patient data between systems. Specifically, I will discuss issues pertaining to the HL7v2 protocol. In depth, HL7v2 is the most prominent protocol used. About 95% of interfaces are implemented using HL7v2, so this is the protocol when it comes to transmitting patient data. And I will review some of the most common vulnerabilities that affect systems that handle this protocol. Security issues are sort of present as a baseline when dealing with this protocol, and this talk will have less to do with specific EMR, EHR systems and more to do with the protocol, HL7v2 itself. So this talk is intended for healthcare information technology specialists, technical staff who will interact with or manage EMR, EHR systems, sysadmins, IT people, etc. Also penetration testers and auditors who may perform assessments where you will encounter EMR, EHR systems, so medical facilities, treatment centers, pharmacies, etc. Security researchers who are curious about healthcare information technology security and the protocols that are used for patient data. When we're talking healthcare, everything is going to have some kind of HL7 component if it interfaces with another facility or a diagnostic tool like a radiology machine or something like that. So medical device communication protocols. Again, this talk is all about the protocols. So medical device interoperability refers to the ability to effectively transmit and process information among multiple platforms. So EMR system, your vendor, your pharmacy, it's all about interfacing those in between. So information that is exchanged can then be displayed, interpreted, or stored on another product, or can be used to automatically act on or control another system. For example, if I am a physician and I am sending a prescription to a pharmacy, it will automatically act on that, depending on the type of prescription. It could, send it to a pharmacist to fill, things like that. As with my previous example, more and more things are being electronically transmitted. In New York State just mandated 2 years back that all controlled substances are sent over e-prescription. So, we're starting to see that now, and there's a lot of considerations there. So, over the years, several protocols have been created to kind of standardize data transmission and aid in the communication across these devices and platforms and products. And all of these transmissions, they typically occur over, hopefully, HTTPS at the very least, or another secure transmission mean, and also are, generally XML formatted. So. Short history of medical protocols. You see the slide, it is not very short, so I'm going to TLDR it. Okay, TLDR, patient data was going to be transmitted electronically, right? I think in the 70s, we realized eventually these things will be managed by computers. And this resulted in the use and creation of several protocols and standards over the years, with eventually one reigning supreme and being widely adopted. But this was an old and slow effort, and it's difficult to adopt change, especially in healthcare. And the industry sort of hovered over HL7 as a protocol, and specifically HL7v2. And I'll go into some reasons why this was the case. So HL7, the protocol, the focus of this talk. HL7 protocols are the most widely used protocol for the transmission of healthcare data worldwide. And it is the international set of standards for the transfer of administrative and clinical data in between software applications used for various healthcare providers. So. The HL7 standards focus on the application layer of the OSI model. All people seem to need data processing application layer on the top. And they interact directly with software applications such as the EMR, EHR system. So these standards are used by other bodies, including, as you will see, the International Organization for Standards and American National Standards Institute. HL7 is the deal when it comes to healthcare data transmission. So let's take a look at the HL7 protocol and its versions. So we have this chart here. HL7 v1 never really hit production. People didn't really use it. So HL7 v2 was also known as pipette, was like the first widely adapted HL7 and like healthcare transmission protocol. They call it pipette because like pipes and hats are used as the delimiter in the XML message to kind of like separate the segments in the fields. You'll see these messages are in plain text. They're very easy to read. And it's really just based on like the transmission of the data in a format that can be like interpreted easily. Security considerations were not kind of put in here. They're plain text, authentication is not supported, encryption is not supported natively. HL7 eventually developed v3 of the protocol, which was more robust and it had security considerations such as supporting cryptographic signatures, encryption, and other stuff. But unfortunately, it was not as widely adopted because people considered it to be too complicated to configure. Setting up those certificates and configuring and all of that stuff. It was very hard in the e-prescribing phase to get prescribers to use multi-factor authentication that required a certificate. People didn't want to do that. But that's another reason why the industry kind of hovered on v2 of the protocol. I won't really critique HL7 Fire, which is the bottom one pronounced Fire in this talk, as it's still under development, and hopefully it makes it into the wider protocol canon, as it has security considerations similar to v3. I think it'll probably be adopted by the industry. I'm not too cynical here, but now it is time for that cynicism. So, built-in insecurity. All right, let's take a look at what lovely protocol we have running on your network. HL7 v2 has no encryption, no message signing, and no authentication. So the messages are plain text, not encrypted. They are not cryptographically signed. You cannot verify from where they came or the integrity of the message. And no authentication. You do not require authentication to interact with an HL7 interface, HL7 v2 interface, unless, of course, they are using like a VPN tunnel, but often this is not the case. So what protocols do you think these can be transmitted over? Well, any protocol really, as you'll see later in the talk, it doesn't require the use of any particular one, so you can totally transmit messages over FTP or HTTP. Are you cringing yet? No, but there's a reason that medical is infamous for poor security. It might have something to do with this protocol that everybody uses. So the HL7 protocol in detail, again, referring to HL7 v2. So how does an HL7 v2 message look? Thankfully it's in XML and in plain text, so if we look at a sample message as we soon will, you'll be able to follow along and see what it looks like, this message. So the messages consist of a group of segments in a defined sequence. So we have things like the header of the message, other parts of the message saying what type of message it is, its payload, what it contains. So, like for example, type of message. It can be like a message to admit a patient, discharge a patient, a message saying, hey, I'm the results of a laboratory test, things like that, and a trigger event. So for example, I'm the results of a laboratory test. Is lab results, here are the results, or, requires results, etc. And this is located in the message header. So looking at an HL7 v2 message, we can see in the header exactly what kind of message it is and what warranted that message to be sent. So here's an example message. Okay, it might be a little bit tricky to see, but over on the right, the top is the message, the header section, and in this over here, you'll see, let's see how I can point it out best. Take a look at the fourth field. There are two elements in there, ORU and RO1. So RU is the identifier for results. This is a results message. And what warranted it, RO1, is sending order results, right? So when we're looking at these messages, it's very clear to see what this is. So if you saw like an HL7 message, like cached somewhere like in a log for debugging purposes or whatever, it's not hard to interpret the data. It's just there. You could really just read it. So PID, this field is like the the field that contains most of it. This field is used for patient identification. So this field actually has, this segment has the most fields. It has 30 fields, and they can be used for things such as the patient ID number, which and many times is the social security number because it's convenient and it tends to be unique. This is bad. Because when you can't obscure something such as the ID number, right? The point of it is for identification. Many interfaces will use the social as a patient identifier, but in addition to that, it also has interesting things that are not exactly PII, but sensitive, such as their sex, marital status, religion, birthplace, etc. There are 30 fields, so just think about 30 things about yourself if you were to write on a piece of paper. There are a lot of fields here. Because when you think about healthcare and its considerations, a hospital has to have a lot of information about a patient, their wishes, things like that. Most of it is here. And then OBR and OBX. OBR is observation request and OBX observation result. I won't go into too much detail about this, but it's like the results of the specific thing. Like for example, like blood results, radiology results, things like that. You would think that it's less interesting, but it's really not, because this information can be leveraged against an individual. It's not, social security number, a mother's maiden name, and date of birth to go and get a credit card, but it could be the results of a blood test, which, is pretty sensitive. Think about the implications for that. Okay, on to my next slide. So, security consideration for medical protocols. Right, so to touch on that, confidentiality is of extreme importance, especially when handling PII and HIPAA-protected data and other data. Think about everything that is in the patient identifier field. There are 30 things about a person. To step away from the bits and bytes, it's more than just medical and billing data. If a denial of service occurs, patient data can be lost in transmission with no indication. A lot of these interfaces operate in asynchronous mode for the sake of performance. So there really is no acknowledgement that anything was received. So, you can transfer a patient, and then it is very possible that if there is an issue with the interface, like it received a wrongly crafted message from a vendor who's not familiar with their HL7 formatting, that the interface may not function, and you might never receive somebody's physical therapy results. Things like this happen all the time. So we all know what happens when PII is exposed, such as the date of birth and the social security number, but what about the other information, right? Here's the darker side of it. So, looking at the PID, the patient identification fields such as religion, sex, birthplace, marital status, and much, much more, these are identified. We all know the implications that this can have. What if it was something like a diagnosis or a prescription? Those things would also be part of that field. You could know somebody's status, results, things like that. Well, the PII is, directly valuable in a monetary sense. These other things are valuable in a monetary way. This information has been leveraged for blackmail, and there have been many incidents of this. Well, I will not list any, several have received mainstream media attention in the past years. Next slide. Implementation security considerations. So again, for HL7v2, HL7 is commonly implemented as just a pure XML payload. It's in plain text, delimited by pipes and hats. You can read it. If you familiarize yourself with the HL7v2 guidelines, you can clearly read and interpret by eye, the data, what is it, what the fields are. You need to, every facility kind of customizes this a bit depending on their EMR or EHR interface and what fields that interface has, supports, things like that. When one thing might go from one interface to another, it might be called a different thing, but once you know this, it's very easy to tell what exactly the message contents are. So XML parsers are commonly vulnerable to a variety of serious security issues, such as, we have some here, I'm going to go into more depth on these when I go into the issues. XML external entities, XXE, XML entity expansion, Java deserialization vulnerabilities, in addition to those which come with parsers such as buffer overflow and other ones. Use of memory for denial of service, etc. So we're going to go into the issues now. Issue number 1. No lower level protocol specification, right? So HL7 messages can be sent by whatever protocol you so choose. Again, this is why messages can be sent over HTTP and often are over FTP, a variety of insecure transmission protocols which do not afford any security. One can and often will use these protocols. And yes, sometimes things are done right and it is used in conjunction with a VPN tunnel or SSH, but this is certainly not always the case because it requires difficult and complicated configurations, so we might see some lapses here. can you imagine what would happen when this protocol is implemented without security transport and it's just sent unencrypted and it is plain text? If someone is sitting on your network and they have a listener up, they will be able to harvest a great deal of information undetected, because it would not be a very loud and obtrusive thing to do this. You know what I mean? Like, it's not very difficult. So it is a very serious issue. That's why it's number one. Issue number two is no internal encryption, right? So HL7v2 messages. Data protection at the application level can be difficult to implement. So, you would use like HTTPS, FTPS, which is FTP on TLS, SFTP, safe SSH, or VPN tunnel, and these standards were not considered best practice at the creation of the HL7v2 protocol in like 1994. Yeah, back to that slide. So we can understand why it was not part of it. So HL7v2 does not support encryption at the protocol level, and the messages are formatted in plain text. And without the presence of transport or internal encryption, confidentiality is just thrown out the window. The simple observation of traffic would reveal plain text and conveniently formatted confidential patient data. So again, these messages do follow common formatting. You could decipher what they mean. It's not like, oh, what is this thing in this field? It's obscure, I can't tell. You can always look at the HL7v2 guidelines and figure out that it's like, oh, that's diagnosis, things like that. So it can be interpreted. So, issue number 3, no CRC. So, HL7v2 protocol does not provide a CRC. So there is no integrity protection at the protocol level itself. And this may be redundant in some cases because you may be transmitting something that is pretty static and will not change, like their name or their date of birth. But there are cases where this might change, or this could be corrupted, or it could be sent incomplete. Because there is no CRC, you cannot really tell when a message is incomplete or corrupted, because, like I said, there are many fields for these different segments, and depending on the EMR EHR system, it's not uncommon for only a small subset of these fields to be in use. More simple EMR EHR interfaces are not going to support as many fields, so if HL7 message comes in with only 3 or 4 fields, it's not abnormal. The interface kind of just has to accept it by design. So again, I'm talking about a data corruption integrity issue, not a middling issue. I already went over these. Corruption and integrity, that's its own consideration entirely. Imagine getting incomplete or corrupted messages, right? So an incomplete or corrupted message could have many adverse reactions. Imagine a diagnosis or a prescription field becoming corrupted or lost in transport. Or the field which says who your previous physician was. If that doesn't come over, you don't know who their previous physician was. You can't really check with them to request records from the patient. You can't really, you might miss some prescriptions that should be part of their care plan. You might not know their relatives to contact. And this is the most commonly lost information, because interfaces change, they account for different fields. This is a huge issue. It may not seem like it from a security standpoint, but it really is when you think about the availability of data. So, issue number 4. No authentication. Authentication is not supported by the protocol. If you have an exposed HL7v2 interface, you can, on the internet external WAN network, you can just interact with it. You can download a HL7v2 message, program to help you craft the messages if you're not used to doing it, yourself by hand, or if you don't have the template. It is very easy to craft these messages, and you can just send messages to an interface. And because there is no authentication in there, you could try and enumerate information. Let's say I know a certain patient, like Alex Ivanov. I can try and send a message saying that they have certain results or whatever. There's no authentication. There's no one to stop. And if you hit all of that right, or just enough of it right, you might be able to actually write something to their record if that interface takes it. And just another consideration, think about your local hospital or urgent care center. How many places will they interact with? At the very least, a hospital's going to interact with a pharmacy, a radiology place, a lab for testing, maybe a physical therapy place, perhaps a number of local physicians and all of that. So there's all of these different interfaces to external entities, right? Do you think that the local physician's office is going to configure a VPN tunnel to send information to the hospital? No, they often don't. How about the physical therapy place? Maybe they don't want to renew their certificate and they're doing it by HTTP. This happens. So maliciously crafted messages can also be used to cause a denial of service. If you're, you could potentially just like write nothing to the records and update the records with nothing. If you had a list of names, which might not be hard to enumerate, it's endless. Authentication, big deal. Okay, issue number 5. Lack of cryptographic signature support. So HL7v2 does not support the use of cryptographic signatures in the protocol. And the lack of cryptographic signing may allow attackers to middle the messages. So because of this, in addition to like middling the message for just like the sake of like harvesting them and having the information, you can also like middle the message, alter it, and send it on its way. So, you know, don't want to fail that drug test? That's something that's doable. I don't want to say it, I don't want to be that guy, but like Mr. Robot did that. You know, messages can be intercepted in altering, which, again, that's a threat to integrity, of course, because if the opportunity is there to change the message and send it or update it, you know, the sky's the limit. These messages cannot, like, be trusted. Issue number 6. Synchronization and asynchronization, right? So I said earlier, HL7v2 messages are often, like the interfaces often operate in asynchronous mode, and this is for performance because, you know, a lot of results may be coming in, and if it's done in synchronous mode, it would take a lot of resources to, you know, send an acknowledgement back or something like, hey, message is improperly formatted, or like, you know, what about this field or whatever. It often doesn't happen. So, you know, HL7v2 interface is there, standing, and then you just like throw messages at it. If the interface kind of like went down because it got an improperly formatted message or something happened or the service didn't start on the server or whatever, your lab and your pharmacy can be sending you messages and you will not get them. And you don't know that you didn't get them either because there's nothing to say that you didn't get it. It's not logged in that way. You definitely have a log of the messages that you got, but not the ones that you didn't. So again, it's very possible to create a denial of service attack against an exposed HL7 interface, and the implication for that is that you would be missing messages that you don't know that you missed. Yeah, happens all the time. Issue number 7. So we're going into the vulnerabilities that pertain more to like the XML parsers, which every HL7v2 interface is going to have a XML parser because it has to interpret the data and kind of like get it into the EMR or EHR system. So this one, XML external entity, XXE attack. XXE enables the attackers to disclose normally protected files from the server or a connected network, you know, externally off of that box. Some XML parsers allows for the declaring of external entities in doc type. So many of these parsers have this enabled by default. If the parser for the HL7v2 interface allows for either of these, you know, the ability to define doc type or external entities, it is possible to perform several attacks. For example, this is an example right here. You could define an entity that is the contents of etc password, right? Which etc password on Linux is like the file which would contain like hash passwords. Or any other file, local file. You know, if you want to get like a configuration file from like the interface itself because you want information out of the interface, or any other thing that you can think of, if you can kind of like enumerate the file name, what location, and things like that, you could potentially get that through XXE attack. And this attack cannot be mitigated by external controls in the case where where there's security issues with HL7v2 that are, you know, part of it and not supported by the protocol. You can kind of like band-aid that with good transport, you know, method like transport encryption and things like that. With this, it is really up to the developer to make sure that the ability to define doc type and, you know, declare external entities is not enabled. It's not allowed for the parser to do this. So, you know, you can't really do anything about that one. Issue 8 is XML external entity expansion. This is XXE attack. And this one is just a straight denial of service attack. So here's an example of it. It's also known as the XML bomb or the billion laughs attack. And the billion, so look at this here. So we have this XML message, ignore the header. So it's declaring the doc type, again, a thing that should be disabled. And it's defining an entity, lol, in lols. And you can see like recursively, you know, lol2 entity consists of 5 lol1s, on and on and on. And it keeps like defining these entities recursively. And what this would do with like the XML parser and, you know, ultimately the interface is that it would choke because this would take up a huge amount of memory. And, you know, again, like I've said, when an HL7v2 interface goes down, if it's operating in asynchronous mode, it's down, you don't know that you missed things, your EMR is down. So that's a huge one. So, how do we test for these issues, right? When you think about it from like a pen test perspective, whenever you encounter this, like test for encryption, right? How are the HL7v2 messages being transmitted to the interface? You know, is encryption present in the transport? Is it done over VPN tunnel or by SSH or by FTP or HTTP? If so, you know, if it is encrypted and it's done the right way and, you know, configuration is done the right way by at least one person, is there a point where this lapses? Either in transmission or at rest? You know, these messages can have like several hops as they go across like different points of the network and ultimately make it to your EMR or EHR application server, right? So you want to think about like where they come in, is that encrypted or is it passed to the application server because it's on a different, you know, part of your network? Or are the HL7v2 messages logged in, you know, some location for debugging or troubleshooting purposes? It's very common to log and it might seem counterintuitive, but it's very common to log the entire HL7v2 message for troubleshooting purposes, because when you are implementing a new interface, perhaps with like a new vendor or new software or something, getting the HL7v2 format correct is a lot of trial and error. So these messages are logged, and often like they'll go live because with, you know, healthcare, they just want to push, get it done, get it there, have it, adapt it, be the best, you know, be on the bleeding edge, the insecure bleeding edge. So, you know, test for that encryption, look for the lapses, see where things are cached. And you know, test for authentication. How is access to the interface controlled? Like, what controls are they using? Is it just an HL7v2 interface that's sitting externally, like on the WAN, on the internet, that requires no authentication because it's not done over, you know, a VPN tunnel? Things like that. This is not uncommon. Again, many vendors, labs, and pharmacies can be used by just one small facility or local doctor even. And this is another example of how security controls such as authentication are difficult to retrofit for HL7v2 protocol because configuration, management, time, you know, you don't want to have a case where you're trading like security for availability and you're doing like all of the security controls so stringently that you're like causing an availability issue because, you know, people can't correctly interface with your EMR and not all of your results are, you know, supported by your EMR because you're not being compatible and flexible there. So sysadmins usually just pass on this and take the lazy route from what I've seen, either by pressure or by just laziness or ignorance or whatever. It's a number of issues, but it happens a lot. It's definitely something to test for. And again, this is why HL7 interfaces are especially susceptible to denial of service attacks, right? Because when you are looking at the kind of like attacker who would want to, you know, cause a denial of service attack on your system, it's going to be somebody external, you know. When you have something that's sitting out there on the internet to poke, people will poke it. People will port scan your stuff all the time, and if they discover an interface there, like, they're going to play with it. And there's nothing to stop you from doing it. Authentication's not required. So, again, like, you might look for things like data leakage, you know, if it is in synchronous mode, you know, what's in the acknowledgement? Like, if I see, like, an exposed HL7v2 interface, and I send something to it, it's not in asynchronous mode, it's in synchronous, and it sends something back in the acknowledgement. Is there information in that acknowledgement that it can like enumerate to kind of tell how to craft the HL7v2 message, specifically to interact with them the right way where it is accepted? It's possible. So, not done quite just yet. You know, conclusion and considerations. Virtually all EMR and EHR systems, typo, use a medical device communication protocol, which is very insecure. It offers no built-in security. They expect you to retrofit everything. But that's really not the expectation because, again, there's the forgotten HL7v3, which does support all of this, but nobody supports it because it's just too much trouble. So the data transmitted is both critical and valuable. It's more than just PII. It's all of the patient data. Again, 30 fields, all sorts of things, diagnostic results, prescriptions, everything else. There's a lot of value there to be had and to be protected, really. And it's really difficult, again, to retrofit these controls in complex environments where you have a lot of vendors, some that are small, they don't have their own IT department, they contract support from like a small consulting place that's not familiar with like HL7v2 interfaces and how to like really secure them because healthcare and confidentiality and integrity and availability are especially at risk, as we have seen in all of these like major issues. All of these things are, you know, endangered by the lack of security controls in HL7v2, the protocol which they all use. So, What if you're a sysadmin in a healthcare place, or you work in it, or you're an IT person? So what are some of the considerations for people who like have the burden of having HL7v2 protocol in their network, right? So be mindful of your interfaces, track the route of your messages in and out of your interfaces. From where do they come? What are the stops that they make? Where do they reside? How are they being transmitted? Where are they received, stored, cached? Is encryption in use, transport encryption? Are the keys for your chosen method unique, secure? Does the interface log messages for debug and troubleshooting purposes? If so, is that location secured? Let's see, and consideration for testers, pen testers, people who just want to poke at it at your own risk. Happy hacking, find the interfaces. They're definitely worthwhile targets, because many of the interfaces may be present with several coexisting on the same host, which is often like the application server itself. A wide range of ports can and will be used because it's common to have many interfaces on the app server for each of the vendors. Scan all the way up, identify them, and don't give up. You can interact with these interfaces directly. It might take some troubleshooting to kind of like get the message format correct to get the result that you're looking for. But if you read about the protocol and how it is formatted, you can get success here if you persist. So, and if you're testing HL7v2 interface in a production environment, I highly suggest arranging for a test record ID to be provided to you, because everything on there will have to do with a real patient. So if they are doing it by a social security number, which they shouldn't, ask them, which test IDs are in use. Is it all 9s, all 1s, all 0s? Don't just try to pick numbers here because you might hit a person. And the interfaces are extremely fragile. They can stop, the service can stop responding if the message is formatted incorrectly, or if any other condition, caused it to drop down. And it's difficult to recognize a disruption in the service if it is, done with asynchronous transport, because, you're not going to receive an acknowledgement back. And, thanks for coming. I hope it was a quick and easy talk. EMR, it's healthcare has the reputation it has for a reason. And, contact us, or me, or whatever. All right, thanks for coming.